carrying on with functions, we're going to get into constructing functions. Your essential question, how can we model relationships between quantities? Several different I can statements. By the time we're done with the lesson, you're going to be able to say that I can create an equation to model two quantities that are linear. I can determine the initial value when given a linear relationship shown by a table or graph. I can explain what the rate of change, and that should say, and initial value means when given a linear relationship in a real world situation. So kind of a reflection of everything that's building up with these functions. All right, let's talk about some terms that you're going to see. This is all prior knowledge, this is all review. However, you might see a new term, which is this initial value. So we'll get to that in just a second. Remember that rate of change is that change in y over the change in x. So when we think of that, we think of that formula that we use to find slope. Change in y as your numerator divided by the change in x as your denominator. So remember, the change in y always goes at the top of that ratio. Rate of change can also be referred to as the slope or the constant of variation. So when we talk about slope, that's a common word you're going to hear. That also means that rate of change. All right, your y-intercept. That is where the function or the line crosses the y-axis. And very important for what we're doing today, the y-intercept, remember that is the starting point, but the term you're going to hear it referred to as in this section and some of the problems we're going to be looking at is initial value in the functions. Okay, so y-intercept is going to be referred to as what is that initial value, or interpret the initial value. They're talking about the y-intercept. All right. When constructing functions from tables, graphs, or real-world situations, you want to kind of follow these steps. The first thing is obtain two ordered pairs. It might be two ordered pairs that are given to you in a word problem. It might be two ordered pairs that are given to you in a table, or two ordered pairs that are graphed on a line. Get those two ordered pairs. Use those two ordered pairs to find that slope or the rate of change, which is that m value in our slope-intercept equation. So use the two ordered pairs that you got to find your rate of change or your slope. And then last, you're going to use that y equals mx plus b equation to get the y-intercept or that initial value or amount. So you're going to have two ordered pairs. So out of those two, you can get an x and a y. You will then have found the rate of change or the slope, which is your m. You then have three values you can plug into this equation to find b, which is your y-intercept. So that's what we're going to look at with our examples. All right, first example. An education association wants to rent a cotton candy machine, misspelled, so sorry, for a carnival. There is a deposit to rent it plus an additional $8 per hour. The total cost to rent the machine for 5 hours is $115. Assume the relationship is linear. Write a linear function equation to represent the situation. Interpret the rate of change and the initial amount. So a lot going on here. Now, if you remember in the previous slide, we looked for two ordered pairs. In this situation, they don't give you two ordered pairs. They do give you one though. They also give you that rate of change. Remember when you see that word per or for each? That is a value that's representing a rate of change. So for this particular situation, to rent that cotton candy machine, they're going to be charged $8 per hour. So that $8 is going to be that rate of change. That's going to be our m value. Okay. They also tell us that the total cost to rent the machine for 5 hours is $15. So what we're looking at here are two quantities. We're looking at the number of hours, which is going to be your independent, and then the total cost, which is that dollar amount. Remember, we have to know how many hours we're going to rent the machine before we know how much we're going to have to pay. So the total hours will be that independent, or that X. So what they're giving us is an ordered pair. 5 hours means we're going to have to pay $115. So they gave us an X and they gave us a Y. Now they also gave us that M value because they gave us that rate of change, $8 per hour. So we can use the slope-intercept equation, y equals mx plus b, and plug these 3 values in. We'll solve it for b. So let's put 115 in for y. We're going to put 8 in for m and 5 in for x. Now we're just solving the equation to find out what b is. 8 times 5 is 40. When we subtract 40 on both sides, b will be equal to 75. Okay? Now let's talk about what that 75 means. They want us to interpret the rate of change. Well, we know the rate of change is 8 and the initial amount. That's what we just found. So let's write an equation from this. I'm going to erase this, get it out of the way. We know that m is 8 and the b is 75. So that means our equation is y equals 8x plus 75. The total cost, remember that's what our y was, is equal to $8 per hour plus 75. That 75 is the initial amount. And pretty much, they're going to charge $75 for the deposit. So that's what that initial amount means. They have to pay a deposit and they also have to pay an hourly fee of $8. So that's what we mean when we interpret those rates of change and initial amounts. So when this education association goes to rent that cotton candy machine, the first thing they got to do is pay the $75. That's the starting or the initial amount. Then they're going to have to pay $8 every hour that they use that machine. Let's look at one more example. The table, example number 2, the table shows the monthly cost of sending text messages, assuming the relationship between the two quantities is linear. Find and interpret the rate of change and the initial value, and then write an equation. So this one's given to us in a different form. We have it in a table. We have 3 ordered pairs. 5 messages will cost us $10.50. 6 will cost us $10.60. 7 will cost us $10.70. So remember, use 2 ordered pairs to find your rate of change. They didn't give us the rate of change in the problem this time. We have to find it on our own. So remember, it's the change in y, and in this case, it's an increase of, it's like 10 cents, over the change in x, which in this case is a 1. So it looks like 10 cents per message. Make sure it's consistent. Again, an increase of 10 cents for 1 message. So the rate of change is 10 cents per text message. Okay, that is the M value, the rate of change. So they're charging 10 cents per message. Now we also want to know what that initial value is, or the y-intercept. Remember, this value here we just found is the M, the rate of change, or the slope. We can also get 2 more values we need, an x and a y. It doesn't matter which of these 3 ordered pairs you use to get your x and your y. Just make sure it's the entire ordered pair that you're using. So we're just going to use this first ordered pair. 5 for x, $10.50 for y. So again, we're going to put these three values into our slope-intercept equation. We're going to put 1050 in for y. We're going to put 10 cents, 0.10, in for m, and 5 in for x. Solve for b. 10 cents times 50, or I'm sorry, 10 cents times 5 is 50 cents. And then we have 1050 over here. Subtract that 50 cents from both sides. You seem to always run out of room. So when we cancel that out, we have b by itself. B is going to be equal to 10. And in this case, that's going to be $10. Okay? So let's look at this. I'm going to erase this work here. Make sure you have it in your notes. And then we're going to use the slope and the y-intercept to write our equation. Okay, so our m value is 0.10. So we're going to put it right in place of m. And our b is 10. So in this situation, x, remember, was your number of text messages, y is your cost. So the total cost is obtained from 10 cents per text message plus $10. This $10 is an initial fee, okay? That is a, sometimes they can call it a startup fee, maybe it's a monthly fee, but that is that initial fee. It's a one-time charge that they will put on your bill. Now this is the one that can go up and down. That's your rate of change or your slope. This is your 10 cents per message. That is that rate of change. So you're going to start at $10 on your bill, and then it's gonna, your bill will go up 10 cents for every message that you send. So again, there's our equation and our interpretations. Okay? We'll be doing more examples in class, so make sure you have all of the examples in the video down in your notes, and we'll do a little more when you see me.